Hey everyone, this is Mike Leone, Senior Analyst at ESG covering blockchain. I get questions from family, friends, colleagues, clients, other vendors, always asking, what is blockchain? There are search results out there like crazy, so I'm chiming in with my take. Blockchain is a publicly available distributed digital ledger of data and transactions made between parties. Data gets hashed. The hashed data gets placed in blocks based on a predetermined block size. Blocks get chained together. The chains get distributed to provide a consensus of the truth, and through that distribution, immutability is provided. Let's start with hashing. Hashing is a way to transform or encrypt a readable, understandable string into a 256-bit signature of that text. Now, numerous hashing algorithms exist, but for this example, let's use SHA-256, which happens to be used by Bitcoin. SHA-256 is a one-way cryptographic function, meaning it cannot be decrypted back to the original text. The only way to figure out what was hashed would be to take the hashed versions of text. So here's an example. If I simply take the lowercase letter a and run it through the SHA-256 hashing algorithm, you get a long and confusing combination of letters and numbers. Now here are three minor variations with their subsequent hashes. Capital A, lowercase a followed by the number 1, and capital A followed by the number 1. I think you get the point. So the next thing to note about hashing is that the string to be hashed does not have a size limit. Whether a letter, a name, a transaction, or even the full text of the US Constitution, when hashed, will provide the same length of an unpredictable mix of letters and numbers. Now that we understand hashing, let's move to the concept of a block. What goes in a block? Each block contains hashed data, as well as information about all the previous blocks in the chain. Let's imagine I'm starting a new blockchain. Each block has fields of information. We have the block number, in this case it's the Genesis block, or block 1, some data, the hash of the previous block, again in this case it's 0 since it's the first block, a nonce, I'll cover that in a second, and then the underlying hash of all the data of the block. Let's imagine an underlying rule for a block to be officially signed and valid is that the hash of all the data in the block number, the data, the previous block hash, and the nonce, must begin with 4 zeros. It's important to note that in the real world, the rules or difficulty, they change. Here we're using 4 zeros. A much harder rule would be starting with 8 zeros. Difficulty can change over time. In some cases, difficulty just continues going up. In other cases, difficulty can get harder or easier with every new block. For simplicity, I use the letter A as the data. You'll also notice a nonce is set at 78,061. And that combination of information allows the hash to meet the rule of starting with 4 zeros. The interesting part is that if any of the data changes, the underlying hash changes, making the block invalid. When changing the data to A1, notice the hash changes and now it no longer starts with 4 zeros, meaning it's not a valid block. This is where the nonce comes in. The nonce is an arbitrary number that can be changed to try and validate the block, so it meets the hash requirement of starting with 4 zeros. Starting with a nonce of 1, we can cycle through nonces until we find a valid solution. 1, 2, 3, eventually, a nonce of 9,352 works and provides a valid hash. The concept of finding a valid nonce is called mining, which is essentially guessing if a nonce validates a block. The concept of mining, or proving a block is valid through the completion of work, deserves a video in and of itself. Further, there's more than one way to validate a block. Proof of work, as I just mentioned, another is proof of stake. Now that we understand what goes into a block, the next step is chaining them together. Let's take our original block 1 and add a few more blocks that have already been validated, 2, 3, and 4. Block 2 contains again the block number, some data, let's use B. You'll notice it now has a filled out previous block field, which is the hash of the previous block, a valid nonce, and a new hash for that block. The same process follows for blocks 3 and 4. What this means is that when looking at the last block in the chain, it has all the information about every block before it. The cool part here is that if I was to go back to block 2 and change anything about it, it will impact every block in front of it and invalidate all of them. Changing the block 2 data field to B1 changes the block's hash, so it doesn't meet the 4-0 requirement. This has a domino effect since that hash is used in the previous field for the next block. To fix it, you'd need to find a new nonce for the second block, which would take some time. Then find a new nonce for block 3 and a new nonce for block 4, all of which takes time. The more blocks in the chain and the farther you go back in time, the harder this process is to complete. This concept provides the first level of immutability. Now let's imagine someone was able to change a block early in a blockchain. They'd have to remine every block until the last block was mined, essentially changing the past. How is that prevented? This is where the 2 additional core concepts of blockchain technology come into play: distribution and consensus. Here's the 4-block blockchain, but now there are 5 copies of it stored in different locations. And just to be clear, in the real world, there are thousands of copies of full blockchains run by nodes all over the world. But for educational purposes, let's stick with our example of 5. The 5 copies of the blockchain all contain the same data, the same hashes, the same nonces, and so on. So 5 copies, and all 5 nodes are providing a consensus of the truth. They are saying, we all agree this is a valid chain of validated and signed blocks. Now, if anything's changed anywhere in any of the blockchains, a quick check across all the chains will prove that the one changed blockchain differs from the consensus. Even if that changed blockchain gets mined to validate individual blocks because the hashes don't match the other 4 blockchains, it will still be considered invalid because it does not match the overall consensus. Make sure to check out my other blockchain video on why it matters to you.